Okay, so we're at number 5 of 3.1. And I'm going to make some little columns right here just to make these notes make a little bit more sense. So I'm going to start, the first column is going to be growth versus decay. As we look at our graph, it will either be growing upward as we go or going downwards towards the horizontal asymptote. So our first column will be growth or decay. And then the second thing I care about is end behavior, okay? So end behavior, we're going to make 2 columns for that. One for when x approaches positive infinity and one for where x approaches negative infinity. Remember at the very beginning of the year, our end behavior was like this. We'd write like as x approaches negative infinity, y approaches whatever. Do you guys remember doing that? Yeah. Okay. We then recently learned a limit notation. And the limit notation looks like this. It says limit of f of x. And then underneath it, it says x arrow positive infinity. And then our answer was what that limit was. This is another way to write end behavior. It means the same thing. It's saying, what is my function? What is my y doing as x approaches positive infinity, okay? So that's the question we're going to ask ourselves for that first column is, that second column, limit of f of x as x approaches positive infinity. And then we will do the same thing, limit of my f of x as x approaches negative infinity. And both of those answers will just be numbers. It will just be the number that we get as we approach positive infinity and negative infinity. Okay. And so yesterday we had to make sure that we did our little transformations because if we didn't, we wouldn't remember what these graphs look like. And so I'm going to refer back to them on these problems right here, okay? So this first one, I've got this graph, f of x equals 3 raised to the x. We can treat that like e raised to the x, or even the problems above where we did like 2 raised to the x. They're all the same thing. The e, the 3, and the 2 just do a tiny change of like how steep the graph goes. But the steepness of the graph doesn't matter to me. We care about the end behavior, so it's fine where it's at. Remember that my horizontal asymptote here is at 0. And then my graph is approaching the horizontal asymptote, goes through that point 0, 1, and then exponentially increases, goes up. Okay. So make sure that volume's nice. Okay. So is this a growth or decay? As I read this problem from left to right, is it growing or is it decaying? It's growing. This one's the growth one. Yeah. How do you know the horizontal asymptote? Good. It's always 0 unless there's any up or down movement, and there is no plus or minus anything on the end. So there's no plus or minus anything. That's what the parent graph does. All right, let's think about its end behavior. So I'm going to think about as x approaches positive infinity, as we're getting bigger and bigger and bigger, what's my graph doing? Goes up. So it's going to be approaching positive infinity. Similarly, we're going to think about what's happening when x approaches negative infinity. So we're going to go in the other direction. What is my graph doing at the left end of the graph? What's it getting closer and closer to? 0. Good. It will never ever cross 0, but it's going to get closer and closer and closer to 0. So that's what the limit is. That's what my end behavior is. So that first one was a growth. The limit of my function as x approaches positive infinity is still positive infinity. And then as x approaches negative infinity, it gets closer and closer to 0. Okay. We're going to do the same idea for letter B. This one says f of x equals 3 raised to the negative x. Ooh, do you guys remember what that negative does? It makes it 1/3. It makes it 1/3. Chase, what it across the x-axis. Flips it across the x-axis or across the y-axis? Y-axis. Let's go back and look. That looks like this one. It flips it across the y-axis. So it's just flipping it across the y-axis. So everything else is the exact same. Throw my little graph right here. But instead of starting low and going high, it's going to start high, go through 0, 1, and then go closer and closer to that horizontal asymptote, which is still at 0. Now, as I read this problem, as I go across the page, is it growing or is it decaying? It's decaying. It's getting closer and closer to that 0. So it's going to be decay. So letter B is decay. And let's think about our end behavior. As x approaches positive infinity, what's my graph getting closer and closer to? 0. Okay. And then as my function, as my x approaches negative infinity, what's my graph doing? Positive infinity. It's getting bigger, bigger, bigger. So they're just flipped. Right. I'm going to argue the next two answers are one of the ones that we've already done. Okay, so we have to think about, is C a lot like B or A? And then same thing with D, is it like B or A? So let's look at letter C. It says 1/2 x. It's like B. Why deny?
Because it's split just without the negative.
Good. It's kind of what Alea said. I love that Alea was like on the last one. She's like, oh, that negative makes it a 1/3 x. It's the same thing here. If I want to think about that 1/2, it's the same thing as 2 to the negative power, which we just saw on the graph, right? So whenever we have that negative, it's just flipping across the y-axis. And so that's all like letter B. It's the exact same answers. It's the exact same type of graph. It may or may not be a little bit steeper or less steep than the one that we have drawn, but its end behavior and its growth or decay is the same. This one is still a decay, and it has the exact same end behavior as the other decay. Are you guys okay that the fraction and separately the negative exponent made us be a decay? Okay. Now, I have a fraction, or I guess a decimal, with a negative. Okay. Think about that fraction. That's like 3/4 to the negative x. Yeah, so we could make that 4/3 to the x. It's going to be growth. It's going to be like A. You can also think about it like the fraction makes it flip across the y-axis, and then the negative makes it flip again across the y-axis. So we're just back at the beginning. This is an example of a growth one. So this is like that very first one that we looked at. It's like A. So it is growth. And it has the same end behavior, positive infinity as x approaches positive infinity, and 0 as x approaches negative infinity. As we get into 3.2, probably next class, probably on Monday, we're going to look at equations like this. And anytime you have a number bigger than 0, that's an indication that it's growth. And anytime we have these fractions, that's an indication of decay. So we'll look more and more at that as we get into some more word problems, but we just kind of previewed it a tiny bit here. Do you guys see how the exponents and the fractions affect what the graph looks like and whether it's growth or decay? Okay, awesome. Let's keep going. Okay, well, number 6 is now talking about a new BFF graph. Does anyone remember which BFF graph this would be? Which BFF function is this? It's one of the funny ones. We did not like this one.
Oh, is it the staircase?
Not the staircase. It's another one we did not really like. My logistic function. So I'm just going to remind us real quick, logistic off to the corner. That BFF formula or equation that you guys memorized months ago was y equals 1 over 1 plus e to the negative x. Okay. I don't need you to remember that now. That was just the equation that we remembered earlier. And if you remember also, we had a sketch of the graph. And when we sketched this graph, it had a horizontal asymptote at 0. And it also had a horizontal asymptote at 1. You remembering this? The way this logistic function worked is it went through the point 0.5 and it approached the asymptotes on all parts. So it started closer to 0 and then it kind of snaked its way through and then it approached 1.
Why are some of that 0.5?
That's 0.5. Mm-hmm. So let's think about this. The problem that we're looking at says that we want to find the horizontal asymptote and the y-intercept. The horizontal asymptotes are always going to be, one's always going to be at 0. And the other one is going to be the same as the numerator. Notice that the numerator on this problem that we're looking at right now is 1. And notice that my horizontal asymptote is also at 1. That's not a coincidence. That is a rule of these functions. Okay. So let's do this. Let's go. We have to find horizontal asymptote and y-intercept. Let's do horizontal asymptote first. And just like the last one, I'm just going to make kind of like a little chart so I've got nicely organized work on this paper. Okay. So horizontal asymptotes for letter A, what would they be? Good. And what is it also always? 0. So always 0. Unless there's anything plus or minus over here, which none of these have anything being added or subtracted to the end. So we're just going to do 0. What's my horizontal asymptote for letter B? And 0. Good. And then what about letter C? 9 and 0. Good. That wasn't too crazy. All right. Question so far. Y-intercept is just like we found y-intercepts in the past. We're going to plug 0 in for x. So when we do our y-intercept, I want us to plug 0 in for x. So I'm going to think about it as x equals 0. Okay. You don't need to rewrite your problem all the way out. I'm about to just because I want you to see it while I have it all on the board and I have to kind of put it in small so I can see all the pieces to it. But like, so this first one's going to be 12 over 1 plus 2 times 0.8 raised to the 0. I'm going to challenge you. You need no calculator here. Right? What's 0.8 raised to the 0? 1. It's okay. Several of you said that and several people in C period said it. We're often used to saying what times 0 or what times 0, like what's 3 times 0? It's always 0. But when we raise it to 0, it's 1. So this is helpful because it goes away, but it doesn't completely go away. It just cancels that out. And the 1 and the 2 are left. So I can think of this as being 12 over 1 plus 2, which is the same thing as 12 over 3, which is 4. No, oh, sorry.
Why does it cancel out? Why is it not 1 plus 2 plus 1?
Because it's not being plus, it's being times. It's basically like 2 times 1. Mm-hmm. Good question. And then that would mean my horizontal intercept, or my y-intercept is at 0, 4. Okay. Do you think you can do the next two? Just plug 0 in? Yeah. Okay, do it. I'll have my work on the board. What's up? Press second mode. Let's do C. Well, what's anything to the 0 power? It goes all the way away. Negative times 0 is still 0, and then anything to the 0 power is 1. So e to the 0 is just 1. So I knew that you guys could do that on your own. Sometimes we panic because we're not used to doing that. And I ended up getting 3 for both of my answers. B for B and C. Did you guys get that? Yeah. Awesome. We're going to do a tiny bit more with logistic functions later today, but that's basically all we're doing right this second. Everyone okay? Okay, go ahead and flip your paper over. We've got a few word problems and then a couple problems into 3-2 before we're done for today. Okay, so this is where I said get your calculators because you're going to need them. Now, sometimes we stress out with word problems, but we have the equation for all of these word problems. This gave me an equation. This one gave me an equation. This one gave me an equation. We're just plugging and chugging on these. So it should be very straightforward on these problems because we don't have to write our equation. We just use the one that they gave us. All right, so going back up 7A, it says bacteria growth. The number of bacteria in a Petri dish culture after T hours is given by that pink equation. What is the initial number of bacteria present? What do I need to plug in for T to figure out what the initial amount is? Yes, Alea is 0. So we're gonna plug 0 in for T. Okay. So part A, we're gonna do B equals 100, E raised to the 0.693 times 0. Now, 0.693 times 0 is 0, right? And what's E to the 0? 1. So that's 100 times 1. So my final answer is just 100. 100 bacteria. That wasn't too bad. Letter B says, how many bacteria are present after 6 hours? What do I do with that 6? Plug it in for T. Very good. This one, I would use a calculator. I don't know what 6 times 0.693 is off the top of my head, so I'm going to get my calculator out for that one. But let me first write it over here. Do you guys remember how to do E to a power in your calculator? Let's remind ourselves, okay? I've got 100. Hannah, you nodded your head. What are you going to press? Second and ln. Very good. Second and ln gives you E raised already to a power. It's ready for you to put in an exponent.
Why did you put a negative?
Oh, that's a good question. I don't know why I put a negative. I was gonna say that's not the answer I'm supposed to get. Okay, wait, as I enter E again, you know there's another way of putting E in as well. So if anyone didn't know this, you can also press second division sign and it pops just a normal E. If you want to raise that to a power, then you have to press the caret button after that. So a lot of you guys just go second ln because it gives you E and gives you an exponent ready to go. But if you just need E by itself, second division sign does that. Okay.
What's the difference between it's like when you use 10.
Yes.
Is that the same thing?
No, but we're gonna get into that soon. That's like log stuff, and we're gonna deal with that when we get to logs, which will be not this week. Well, I don't see you tomorrow, so it'll maybe be next week or the week after. There we go. That looks better. Now, I won't be super crazy about rounding, but I just want to think about like the realisticness of this. When it's talking about like bacteria or humans or animals, we can't round up because if we only have like 0.3 or 0.4 of a bacteria, that's not a full bacteria, is it? No, so we keep it at the whole number that we have. We kind of round it down if you think about it. Like I ignore that 0.4 because it's not yet a full bacteria. It's not yet a full human. It's not yet a full, I don't know, lion. So I just ignore that decimal and I just keep it at what it is, what I know I have a whole number of, and we'll say that many bacteria. Again, I won't be super crazy about rounding. I think that is something good to kind of know and think about is we don't care about that point whatever because it's not a full thing. Okay. All right, moving on. Same idea for the next one. This one says the amount of C in grams of carbon-14 present in certain substance after T years is given by that yellow formula. What is the initial amount of carbon-14 present? What do I do? Plug in 0 for T. T times E raised to the negative 0.0001216 times 0. And I'm going to argue again, no calculator is needed because anything times 0 is 0, and then E to the 0 is just 1. So we're left with 20. C equals 20 grams. Okay. Everyone hanging with me so far? Okay. Now, letter B says, how much is left after 10,400 years? When will the amount left be 10 grams? Okay, time out, because that's actually two problems. Okay. The first question, how much is left after 10,400 years? Where does that 10,400 go? T. Very good. So we will do, the first part will be plugging this in for T. Now, the second part, which we'll do together, but where will the 10 go if I want to find out how many years it takes to get 10 grams?
I mean,
Like Y, C, yeah, whatever Y is. So it will be on the other side of the equal sign, which in this problem is C. So let's solve with the 10,400 first. We'll plug and chug that in the calculator, and then we'll figure out how to do the 10 gram one.
how do you edit your name?
If you go to second enter, it will help you. You can like do some of those things. Do you put what? Yeah, I think that seems fair. You can make it 5.6 or you can make it 5.65, whichever one makes you happy. Again, I don't have intense rules with rounding, so as long as I can see that you have the right work and you're close enough, I think it's fine. So 5.6 is good. We'll say 5.6 grams. So now we'll do the second part. So we'll say 10 equals 20e raised to the negative 0.000126 t. Now I want to time out here because in a second, or not in a second, I lied. In like several days, I will teach you logs. And we can solve this by hand using logs. However, I have not taught you logs yet, so I'm going to remind you that we have a different way that doesn't require logs yet. I'm not ready to teach you logs, even if you have a background knowledge of it. Reminder, you have a graphic calculator. When in doubt, we're going to graph both of them and see where they intersect. So I'm going to graph one of them in Y1. I'm going to graph the other one in Y2. And we'll have to mess with the window to see where they cross. Now, you may already have a log background, which is totally fine. But since I haven't talked about it yet, we're not doing logs yet. So go put this in your graph. So I actually have mine still from last period. So put 10 in one of your pieces. Put 20 times e raised to the whatever. And then we will graph them. Okay. Yep. So I'm going to tell us our window is not going to work as is. Okay. We should at least have your y to 20 because remember 20 was our initial amount. So that should at least be where our y is because then it's only going to go down from 20. Y max should be 20. Y min should be 0. Okay.
What about X min?
X min and X max are going to be a little bit bigger, right? So we just plugged in 10,400 and we got 5.6. Do we need to pick a number bigger than 10,000 or smaller than 10,000? Well, we want it to equal 10, not 5. And we got 5 a second ago. So it's decreasing as we go. So we actually need a smaller number. Now, it's not going to be that much smaller. So I think earlier in my class, we tried like 2,000, 5,000. And let me just show you, even if you guessed like, I don't know, 10, you would see that they don't touch. And so that would be a key to me that I need to keep going bigger. I think we ended up doing like 7,000 or 8,000 and that gave us a nice little view of our picture. But I mean, even when we were doing our quizzes and tests recently, sometimes you guys panic with your window. You got to be able to play around with it. You got to be willing to like try a few things and see what do I need to try if I can't see it right now. Does my X need to be bigger? Does my Y need to be bigger? This is plenty big right now. I can see where they intersect. And I'm going to find that point of intersection. So second trace. Uh-huh. I don't know how I messed it up. technically, if we were rounding this right, we would actually make it go 5,701 years, because it's going to go a little bit more than 5,700. It's going to take a tiny bit more than that. So I actually am going to round it up 1 whole year from that. Okay. Again, not super crazy on rounding. I just want to kind of point out what I'm thinking about as I do. Okay. All right. One more word problem for the day. Are you guys ready? All right. This is not an exponential. Do you guys remember what kind of graph this is? What did we just say a few minutes ago? Logistic. Good. It's another logistic function. Okay. This time, this equation is modeling the population, and T is the number of years since 1800. Okay, that's important. Since 1800. So letter A says, what's the population of New York in 1850? What am I going to plug in? Not 1850.
Oh, subtract it.
Good, subtract it. So I was at 1800, and I just want to go to 1850. How many years is that in between those two? 50. Good. So we're just going to plug 50 in. Okay. So go ahead and get your calculator. Let's do that. 19.875 all over 1 plus 57.993. E raised to this negative. Oh, that's a crazy number. And then times 50. All right. I like to plug this in piece by piece, but I have a distrust of calculators in general, just because ours, the older calculators, you had to use a lot of parentheses. So I'm going to plug it in piece by piece. You feel free to plug it in how you would normally plug in, and then see if you get the same answer as I do. Okay. So as I do piece by piece, I'm going to do the exponent first. So negative 0.035005 times 50. I did the exponent. Now I'm going to do E raised to that number. So I'm going to do my second ln and then raised to that number.
Pardon this interruption. It is now time for the choir to leave for the NCYC. Thank you.
Bye, choir. Anyone here, choir? All right. Only a question?
I'm confused.
On what? We just plugged in 50 so far. Are you confused on how I'm doing my calculator? I'm just starting.
Okay.
So I've only done the exponent and then E raised to that.
Okay.
Now I need to do that number times 57.993. And then I'm going to add 1 to that. And then now that's my denominator. And I'm going to do this 19.785 divided by that number. And so I get 1.79. Is that what you got?
Wait, that's what you got. I think that.
That's the very end. So I'm going to argue you're probably off on parentheses.
Okay. Yeah, I have to know.
Did you what I got? Okay, then you're good. Yep, you got to put parentheses on that whole bottom of it. So play around, make sure that you get the same answer as I do, whether you can put it all in at once or put it in little pieces like I do. Now, letter B, we're going to jump to that one. It says, when will New York State's population be, what will it be in 2010? How many years since 1800 is 2010? 210 years. So we're going to plug T equals 210 in. So we're going to do the exact same thing. And again, see if you get the same answer that I do. Again, I'm going to do my exponent. I do E raised to that number. 57.93 times that number. 1 plus that. So that's my denominator. So 19.875 that is 19. So again, make sure that you get the same answer that I get. This time I got 19.16 million. What? I bet there's just some rounding a little bit. So see, I put, like, I carried my answer down and you rounded yours, so that's why I rounded. But that's fine. As long as you show me enough of that work, I'll be like, oh yeah, she just rounded. Okay, are we ready to talk about letter C? Because I'm going to promise you letter C is no work. There's no work to do on letter C. You ready? Okay. This problem says, what is New York's maximum sustainable population? And then in parentheses, it says limit to growth. Limit to growth is your horizontal asymptote. Remember I told you that this is a logistic function, which means that it's modeled after two horizontal asymptotes. What is my horizontal asymptote here? It's 0 and
19.
Good, that numerator. So I have no work to do here for my limit to growth. Letter C is just that 19.875 mil. All right, that is the end of 3.1. We're going to go do a few problems in 3.2, but you have 3.1 due next time I see you, which is not until Monday. So I do not have you guys for class tomorrow, so it is not due until Monday. Cool. All right. Now, because we always do this, yes, right. Because I like to do this, we're going to skip around in 3.2. We're going to skip actually all the way down to 3, 4, and 5. So go ahead and flip your papers around so you get to 3, 4, and 5. Now, the reason I want to do these is we've actually already done problems like 3 and 4. So I just want to reiterate what we've already done, really brain that into your brain. This says, write the equation of an exponential function. Wait, time out. What is the equation of an exponential function? Do you guys remember what we did the other day? Sorry, what? Say it again. That is the basic exponential function, but remember when we used these points yesterday? Said y equals, or maybe not yesterday, a couple days ago, y equals.
Oh, is it the no?
A times b to the x.
I was saying that.
A times b to the x. Remember using that the other day? Yeah. Okay, we're gonna do the exact same thing here. We're gonna start by taking the point that has a 0 in it. We're gonna plug that into this general equation to find A. Then I'm gonna take the new point, the second point, and the A I just found to help me find B. All right. So I'm just gonna kind of remind you how we do this. This first point is 0, 4. So we're gonna do that first. I'm gonna say 4 is equal to A times B raised to the X, which is 0. Well, what is B to the 0? 1. And so A equals 4. Well, that's easy to start with. Now we're going to take that new A, and then we're going to take the other ordered pair that was given to us. X is 5, Y is at 8.05. So 8.05 is equal to A, which we just found was 4, times B raised to the X, which is 5. You guys good with that so far? Okay, let's start solving. What do I do first? Good. Divide that 4 over. 8.05 divided by 4 is 2.0125 equals B to the 5th.
Don't you have to wait?
We're going to do a 5th root. We're going to do a radical with a little 5 power. Okay, time out. Do you guys know how to do that in your calculator? So if you don't buckle up, I'm about to teach you. Okay. Some of you have older calculators. So like Adrian, Adrian, you're definitely not gonna be able to do what I'm about to do. Veronica and Alea, it's gonna be a toss-up. Okay, most of you don't have to type anything in. We're gonna go directly into math. Go to math and scroll down to number 5. See how it says N and then a radical? We're going to click that, and my calculator gives me an option. See how there's like a tiny little cursor right there? it gives me the option to plug a number in there. So that's that number that we're doing the root of, the fifth root. So I'm gonna put a little 5 up there, and then I'm gonna scroll over and type 2.0125 into my calculator, and I'm gonna press enter. So B is going to be equal to 1.15. Okay. Yep, hit math. And then your option number 5 on math, that first menu you see, has an n raised to the radical. Hit that. Oop, now I get an add. And can you use that guy? Okay, perfect. And then you do a little 5 in the top, and then you plug your number in. If your calculator doesn't let you do that, which some of you don't, I'm going to come check on you. I'm going to show you right now. Okay. My final equation for this, though, I'm going to put it back into the original. It's y equals 4 times 1.15 raised to the x. Okay. What I want you to do is try letter B without me, and I'm going to come help those of you with calculators. Okay. Running, yours should be almost there. Okay, perfect. Yours says ANS, which means that it's just going to use the number before. You can come over here and just type whatever number you want. And that's it. So you can just type that number once you get that. Elena, you can do it on here as well. You can press math, and you can come down to that number 5 with the X and see how it has an ANS. Just come over here and we'll type whatever you want. Okay, sorry. Yours is the same thing, so don't press 5. Now, see how it says ANS over there? We just want that to figure out to be whatever numbers. So it can be 5. So you just have to now what you can also do is you press type 5 first, and then you can go to math and find that, and then it's already ready. Yeah. What can you do on yours? Yeah, I think it's figured out. Okay. Yours is not that much harder. You just have to write the top. So whatever your little power of your exponent, you want to write the first word 5 first, and then we're going to go to math and scroll down to that for get confidence. There's that x to the radical, and then now it's ready. You understand that? Okay, go to you probably need to 5 first. And then scroll down to that. See how this power here is radical. Everyone over here good with calculators. Remember you're good with your calculator. Good. Smelly, you good with your calculator. Awesome. All right, let me write the answer for the next one up on the board. This is what you guys should have gotten. Y equals 3 times 0.84 raised to the x. Yep. Did you guys get that? Give yourself high five. Okay. I think we have time for the last problem, so I just want to do one more. I know, buckle up. This one is a little bit more new. Does anybody have any questions on those exponential ones before I move on to the new one, this logistic function? Okay. Okay, now our general form for our logistic, our exponential looked like this. Y equals A times B to the X. Our logistic one is going to be Y equals C over 1 plus A times B to the X. So it's a little bit longer than that one. Okay. A and B are basically the same things as they were in our exponential. C is something new. Okay. C is actually our word limit to growth. Do you remember a minute ago we talked about limit to growth and we talked about how that was a horizontal asymptote? That means if they give me limit to growth, that goes immediately in for my C. Okay. Now, as tempting as it is to put the initial value as A, it is not your initial value. You can treat it as an ordered pair, though. You can treat it as the 0.010, and we can treat that as our first X and Y. So that's what we're going to do. The initial value is not your A. I know we want it to be A. It's not your A. Instead, it makes an ordered pair 0, 10, which is your first X and Y. We're going to plug those X and Y and that C into my equation to find A. We'll use that second point that I haven't shown you yet. We'll use that to find B in a second, okay? So first we'll do 40 is equal to, not 40, I lied, I'm already messing you up, I'm sorry. 10 is equal to 40 over 1 plus A times B raised to the 0. So 10 is my Y, 40 is my C, 0 is my X. So I'm going to cross them out. I get 10 equals 40 over 1 plus A. Now, I don't like this denominator at all. Do you like this denominator? Would you say, Lynn? It can't just be A. We got to solve for it. So I'm going to make it 10 over 1, and we're going to cross multiply to get rid of that denominator. So I now have 40 equals. Do not forget to multiply 10 times the 1 and times the A. You have to distribute it to both of them. So we're going to do 10 times 1 and 10 times A. Say again. You would have to multiply 1 plus A on both sides. And that should give you the same answer as this. So we get 40 equals 10 plus 10A. I actually don't need my calculator, so I'll get rid of that. All right, now I'm going to minus 10 from both sides. So I get 30 equals 10A, and we'll divide by 10 on both sides. So A is going to equal 3. Okay, that's my A. We still have my C. And now I'm going to use this new point X and Y, and I'm going to solve for B. Are you guys ready to do that? Okay, let's plug in. I'm going to do 20 equals 40 over 1 plus A, which we just found was 3, times B raised to the first. 20 equals 40 over 1 plus 3 times B to the first. Okay. Now, we cannot simplify that. You may be tempted to add 1 and 3 together. Why can I not add 1 and 3 together? Good, they're not like terms. So instead, I'm going to cross multiply again. That's my best way to start. So I'm going to do 40 equals, and I'm going to do 20 times 1, which is 20, and I'm going to do 20 times 3B, which is 60B. Times 1 plus 3B. Now, just like we did before, let's minus the 20. Let's divide by 60. Notice that it was B to the first. So I got rid of that 1 because B to the first is just B. I didn't need to carry it through. So minus 20 from both sides. And I get 20 equals 60B. And B is going to equal 1/3. You will often get funny numbers like that, so don't let that stress you out. The last thing I do want to do is plug it all into my formula, okay? So we'll say Y equals 40 over 1 plus 3 times 1/3 to the X. Oh, that looks so jank. That is my answer here. Okay, you guys killed it. How are you feeling? Good. Good. Okay. I do not see you tomorrow. I see you on Monday and Tuesday. All fun, 2 times next week. This homework is due on Monday when I see you next. If I have to see you later this week or early next week to make up your test, awesome. And remember, I do have office hours tomorrow morning and on Monday morning if anyone needs help with anything. Okay? Turn this off.